Good morning, good afternoon, good evening, everyone, wherever you may be in this part of the world. Welcome to another session of my presentation series, and this time the topic is a recloser and a controller, the need and function in a distribution power system network. And the controller type is SCL 651R. My good name is John Amotu, and I've been a professional electrical engineer for the past 31 years. I'm based in the United States of America. Now let's talk about my YouTube channel, right? As you can see over here, the name of my YouTube channel is Work and Happiness. So if you go to the YouTube channel, you'll find tons of presentation material that will be applicable to you as a young engineer, as an engineer that you are about to start your career in the area of power systems, and also as a mid-career engineer and experienced engineer and a consultant engineer. Also, if you like my presentation, don't forget to select the like button and share the material with your friends and colleagues. Also, for you to be able to subscribe to my YouTube channel, you need to have a Google account. To develop a Google account is Gmail. Okay. So once you have a Gmail, you should be able to subscribe to my YouTube channel and any other YouTube channel that will be needing to you. Okay, so now let's talk about the types of faults that are out there in the power system network. Okay, so there are three types of faults, right? The first one is transient faults, and these type of faults is about 80% of the faults that occur. They are called transient faults. The reason being that they appear and disappear within nanoseconds to microseconds. Okay, typical example is lightning strike, right? Okay, so you have a distribution network, and you can have a lightning strike on the phase conductor, right? So once basically the fault ionizes the air and it disappears, right? So it's basically transient faults are very temporary faults. You can also have a tree in a branch, right? Fall on the distribution feeders, right? Okay, so the tree branch can fall on the distribution feeder and basically temporarily and then fall, right? Or the tree itself, based on high winds, depending on the velocity of the wind, can move the tree and its entire branches onto the feeder, where it can cause a face-to-face fall, then move back into its original position. So that is why they call them transient faults, because they are very temporary faults. You can also have vegetation, right? Okay, so vegetation is basically tall grasses and all this that can basically lean on these face-to-face conductors and basically cause a temporary fault. Then you can also have a vehicular, right? Okay, so sometimes people driving heavy trucks, other vehicles can basically run into a pole, right? That can cause a face-to-face fall. Then, when the driver backs out his vehicle, basically everything is restored, right? So that's why they call them transient faults, because they're very temporary, right? And typical example is lightning strike here, where basically it hits direct strike, it hits the feeder for conductors, and basically it ionizes the air. And right after ionization of the air, basically everything is restored back, right? So next is type of faults is about 10 to 12% of the faults that occur. Right? Typical example is a tree branch, right? So you have a tree branch that can lean on the feeder conductors, right? Okay, and stay there, right? It's not the situation where transient faults were basically due to high velocity winds. The tree leans on the feeder conductors and reverses back to its original position. But this one, it leans on the feeder conductors and stays there until patrol operators, basically finds the tree branch and move it back or cut it down. You can also have birds, right? Especially birds that have wider wings, right? That can basically bridge face-to-face conductors and basically cause a semi-permanent fall. And sometimes, when they get electrocuted, due to their wings, and they either fall or basically change positions, due to the electrocution. And sometimes, they hang in there until, let's say, patrol operators basically come and find the bird and basically remove it, right? Then you can have, animals, rodents, squirrels and all those things, they also can cause a semi-permanent fall. Squirrels can basically cause a bridge, face-to-face, conductors cause a semi-permanent fall. And usually it takes the needed action of an operator to basically come there and remove the squirrel, from that position that basically the fall came. Then, lastly, you can have a permanent fault. Permanent fault is about 7 to 8% of the faults that occur. And a permanent fault is basically when you have, let's say, an open face, like broken conductor, or let's say you have a line that had sag and basically the conductor is basically resting on the surface of the earth, or basically resting on the vegetation, or resting on the surface of the sun. You can also have other faults, permanent faults, where you can have when galloping and clashing of conductors, where basically conductors can basically clash, and basically the ionization of the air can sometimes melt the conductors, and they can basically form a permanent fault. Okay, so remember I made mention that a typical transient fault is a lightning strike, right? Okay, so you have the cloud over here, right? And you have a lightning strike on this conductor, right? Okay, so you have a traveling wave, right? Basically, that is going to hit the conductor, but the surface is going to ionize, right? Because of the surrounding air, which is acting as an insulator. So once the ionization is finished, the fault disappears. So that is why they call them transient faults. Another example of a transient fault is the limb of a tree, right? So if you have a tree here and you have a limb that will break off and fall on the conductor, right? So when it falls on the conductor, basically depending on the weight of the limb, right, it can basically force two conductors to bridge together to form the face-to-face fault. Then after that, the tree limb can fall off onto the ground. So that is why they call them transient fault, because it's just a temporary fault that occurs and the tree falls off. Then the conductor basically reverts back to its original sag position. So now let's talk about permanent fault, right? Permanent fault is when the tree itself falls on the conductor and stays there. And this usually occurs during hurricanes, right? heavy winds, tornadoes, right? And other, natural disasters, right? Okay, so that can cause these trees to fall on the conductor in the stage there, right? Until, crews patrol the line to find this tree and start basically cutting off various branches until the tree is removed from the base conductors. So now let's talk about what are and the functions of auto reclosing, right? Okay. So a recloser, right, they are usually pole-mounted circuit switch, right? It's a circuit switch with an automation scheme, right? And it has a control panel that basically provides that automation scheme, which basically has the capability of sensing the interrupting fault current and basically causes the breaker or the switch to open and reclose, depending on the sequence and the number of times it's supposed to open and reclose. And it has the capability of coordinating with downstream fuses, right? Okay, so you can have fuses, pole-mounted fuses, and also fuses that are downstream on the high side of pad-mounted transformers, right? So you can have fuses that are located on poles and also the high side of pad-mounted transformers, right? Okay, so basically you can have pad-mounted transformers that are located in proximity to the customers, So it also has the capability to coordinate with upstream relays in the substations, right? So in the substation, distribution substation, we have feeder relays, right? A typical example is SEL 451 relay that are used as distribution feeder relay. And this relay usually utilizes the following functions for feeder protection, right? It uses 50-51, that is instantaneous and time over current functions, right, on the feeder. And most often than not, the instantaneous is disabled for feeders, unless of course the feeder is directly connected to motors, right? That is when the instantaneous element is enabled. But if it is a direct feeder feeding loads, then it is only the time over current element that is enabled. Also, you can have 50-51N, that is neutral over current protection. That basically protects for ground faults, neutral unbalanced currents that flows through the neutral. Then you can, if you would want a reclosing action of the breaker, right? Then you can have the 79 element as well. That is for auto reclosing. Then you can, for high impedance faults, right? And when does a high impedance fault occur, right? When you have a conductor that basically falls on the ground, on vegetation, right? And because it is high impedance faults, the fault current is very, very small. So there is a unique way of detecting these high impedance faults, right? And the first one is utilizing the ratio of the positive sequence current to the negative sequence current, or the negative sequence current to the positive sequence current. So that is the ratio that is used to determine when a high impedance fault has occurred. Secondly, the high impedance fault is rich in harmonics, right? So when high impedance fault occurs, then there is a harmonic blocking feature that is enabled to prevent this harmonics from flowing back into the source, the power system source. Right? So that is when the harmonic. So these are the elements that are typical for a distribution feeder, and most often than not, the recloser has to coordinate with these 51 elements for the phase, and 51 elements for 51 and for the ground elements. Also, the auto reclosing function occurs when the recloser tries to reclose. Okay, so you have a fault line, right? And the auto recloser is basically programmed to reclose usually 2 to 3 times, right? If the feeder is on overhead lines, right? But if majority, let's say 80 to 90% of the feeder is underground, then usually you don't need an auto reclosing function. So because the fault that occurs is a permanent fault. On the ground cables, if a fault occurs, it's a permanent fault. But for overhead lines, right, like I told you that the 80% of the faults are transient faults, temporary faults. Right? So that is when auto recloser initiates its open and close sequence based on how you program it to maintain service continuity. To prevent, because on the normal circumstances, if you don't have an auto reclosing function, right, and you have a feeder breaker that basically feeds this radio lines, right, and if there should be a transient fault, temporary fault, right, which basically trips the breaker, right, then you're going to lose the whole feeder, and the customers that are on that feeder, let's say 300 to 500 customers, are going to be without power. But if you're able to maintain a recloser in the middle of the radial feeder, it means that not all the 300 or 500 customers are going to be without power. It means that a fraction of it, let's say 100 customers, are going to be temporarily without power due to open and close action of the recloser. Unless, of course, it is a permanent fault. Where 2 to 3 sequence of open and close, if the fault still exists, then the recloser is going to lock out. So that means that it's a permanent fault, which requires a crew action to go there and take a look at it and fix the fault, and basically manually bring the recloser back online. Okay, so the recloser also operates on an inverse characteristic scale, right? Just like a typical feeder relay, right? Which basically the 51 element operates on an inverse scale, right? Where you have, right, time and current over here, right? So that means that the lower the current, you have a shorter time, right? And the higher the time, the higher the current, it means that you have a shorter time to basically operate. Okay, so let me rephrase this again. Okay, so let's take a look at the inverse characteristics, right? Okay, so that means that the lower the current, right, you have more time over here. So as you can see over here, more time. And the higher the time, you have a lower current, right? So that is the inverse characteristics. That's how it operates. And the recloser basically operates on a similar inverse characteristics. That is, the higher the current, shorter the time to operate. The lower the current, the more time you have to operate. And can also have a fast and slow curve, right? Okay, so the slow curve comes into play when basically it allows the downstream fuses to basically take care of the fault, right? And the fast curve comes into play when initially it tries to open and close, right? Because initially the recloser operates on a fast curve, right? Okay, to make sure that it is a temporary fault. But when it determines that it is a permanent fault, then that is when it shifts to a slow curve to allow the downstream fuses to operate. They are really, just like a breaker. So basically, like I told you that you see that the recloser is pole mounted right on top of the pole, right? And the controller is right here, right? If this is the pole, and this is, right? The controller is right here, and the recloser is right here, right? The recloser basically it's a circuit switch or breaker, right? And the controller is the one that controls the operation of the recloser. So the breaker can have a continuous current rating of 800 amps or 1000 amps. And for nominal operating voltage, these are the different voltages that you can achieve on a medium voltage level, right? 15 kV, 25 kV, and 35 kV, right? And short circuit current, they can have like 31.5 kA. Okay, so conversely, right, a circuit breaker consists of a switch and an arc quenching medium, right? So you have a switch over here, right? You have a stationary contact, you have a movable contact, and within this enclosure is an arc quenching medium, which can be SF6 gas. Let's take an example, right? Okay, so on the other hand, a recloser consists of a breaker or switch plus a mechanism to auto reclose and open, and that comes from this controller over here, right? The breaker mechanism is the one that you see on top of the pole. Right. Now let's talk about the type of auto reclosers that we have. We have single phase, we have three phase, right? And you can have the three phase on this pole, right? And single phase, one for each phase. So three of them. You can see three of them on this pole. And you can have the hydraulic auto recloser and electronic auto recloser, right? So the electronic auto recloser is the one that works off from this controller. So these are the modern type of reclosers that we have. Right? Okay. So the older generation of auto reclosing are mostly the hydraulic type, right? Okay. So basically, the breaker itself is basically has all the contacts are immersed in oil, right? And it has a hydraulic scheme that basically operates these contacts that are in this enclosure. Yeah, that is immersed in oil, right? So these are the types of, basically these are older generation, right? And these are newer generation. Okay. So now let's take a deep dive into the different operating states of auto reclosing, right? Okay, so the first one is the reset state, right? Okay, so when the auto recloser is in a reset state, it means that it is ready to go through its cycle process. And at the same time, it has checked that the breaker status, right? 52A contact, right? So the 52A contact is an auxiliary contact, right? That basically tells that if the breaker is closed, right, this auxiliary contact, which is in normal state, it is open contact, it changes to a closed contact, right? So that closed contact from the 52A contact is going to provide a status to the recloser that the breaker is closed and is holding, right? Very, this word over here, right? That means that the breaker is holding, right? And it is closed. So the recloser is ready to go through its sequence of opening, close, open, right? Depending on the number of reclosing sequence that you have programmed, whether it is 2 or 3, before it locks out. Next is the cycle state, right? Okay, so the cycle state is when the auto recloser receives a close command, right? Okay. Most often is about 3 times, right? Okay, so, and also a trip has occurred during the reclosing sequence. Okay, so if the auto recloser receives a command to close, right, from open to close, right, and once it closes, it trips back open, right? That is what is called a cycle state. Then it receives another command to close. So that is basically, what it means by the cycle state. Next state is the lockout state, right? So the lockout state occurs when reclosing sequence, right? You have 2 to 3 times open, close commands, and it finds out that there's still fault on the line, right? Then it trips back out finally and locks out. So that is the final stage. It's lockout, right? And it requires manual inspection and reset. Okay. So next is opening interval, right? Opening interval is close to open, right? And these are the times that is allowed, right? Okay, so the first open and close is 30 cycles. The second one, 600 cycles. And the third one is about 600 cycles. Reset time. Okay, so once the recloser locks out, right, it needs to be reset, right, to its original state, right? And it requires 30 seconds to allow the reset to. Okay, so now a lot of these states you can toggle between the states, right? Okay, so from reset you can toggle to lockout, right? And from reset you can also toggle to cycle state, and from cycle state you can toggle to lockout state, right? And from lockout state you can toggle to reset state. But you cannot toggle from lockout state to cycle state. You have to go back to reset state. Okay, so now let's talk about why the need for reclosers, right? Okay, so if you have a feeder, so this is a feeder coming off from a substation, right? Okay, and this is the substation breaker, right? Okay, and the substation is right here, right? Okay, so if there's a fault here, right, and you have a radial feeder, what happens? It means that all customers on this feeder are going to be without power. So if you should have 500 customers that are on this radial feeder, they will all lose power. So that is the reason why auto reclosing is needed, to mitigate and limit the amount of customers that are going to be without power if there should be the need for a payment fault to have occurred. But if it is a temporary fault, then basically the reclosing action is going to mitigate it, and all customers are going to be restored within the blink of an eye. Okay, so the next picture basically shows us the circuit breaker, right? And a recloser that is dedicated to 2 pad-mounted transformers that are connected, and you have an open loop over here, right? Okay, so like I indicated, if a fault should occur over here, right? The circuit breaker is not going to trip. Rather, it's the recloser that is going to open, and if the fault is a temporary fault, it's going to reclose back based on the sequence and the time lag between each sequence to restore power immediately to these customers. Right? On the normal sequences, if this circuit breaker had tripped, right, all sections of this radial feeder and laterals will be, this is called a lateral feeder, will be without power. So that is why we need reclosers to mitigate customer interruptions, to ensure stability of the distribution system, and to minimize our SIFI index. That is basically one of the distribution indexes that is required, and that is basically standard average interruption duration index and frequency index. So SIDI and SIFI index. So the goal is to reduce these indexes to ensure reliability of power supply to these customers, and also MIFI, that is momentary average interruption frequency index. That is how the momentary dips in power to mitigate that amount of momentary dips that customers are supposed to experience. So these are three indexes that are basically one of the key KPIs for distribution system. That is SIFI, SIDI, and MIFI. SIFI, SIDI, and MIFI. Right? So the first one is standard average interruption frequency index, standard average interruption duration index, and momentary average interruption frequency index. If go to my YouTube channel, right, Work and Happiness, talking to the engineer. If you already have a Google account, right, before you can access these, you need a Google account and Google Gmail, right? Then you can access all the videos that are over there, and that will be helpful for you as a young engineer, development engineer, engineer that you're about to start your career in power systems, mid-career engineer, experienced engineer, consultant engineers. Right? Okay, there's tons of video materials that you will need, especially the younger engineers, the mid-careers, development engineers to develop your career, and also for consulting experienced engineers, you need a refresher. We all need refreshers every year, right? Okay, so if you like my video, don't forget to select the like button, right? And don't forget to share and subscribe. And for you to subscribe, you need a Google account, a Google Gmail, right? So now let's talk about the types of auto reclosers that we have, right? Remember I made mention that we have two types. We have single pole and three pole, right? Okay, so this is this three pole type, right? Okay, where you have three poles on each side, right? Okay, so they are all operated regardless of, that is, both, all three operate together, right? There's no single phase in, right? And sync check is required for it to operate and close, right? So it checks basically voltage in and voltage out for it to operate. So there are set points, right? Okay, for let's say 80% of the voltage is considered to be basically the required voltage for closing in, and also 20% is the voltage that basically is considered that operation will not occur. So these are the typical set points, and sync check relay basically 25 checks to make sure that And also there's a phase angle difference between incoming voltage and outgoing voltage. So it checks the voltage on this side, right, to basically operate, right, and also the voltage on this side if this voltage is coming from another source. Next is single pole, right? Okay, so basically what happens is, there are 3 obliques, right, that are in, each one for each pole, right? Okay, so basically only the 40 phase operates, right? Okay, so if you have 3 phases, right, and the 40 phase, it is only the one that is connected to this phase is the one that is going to operate. And it requires specific relays that is phase selected. A relay that is able to identify particular faulted phase, and it requires that phase to, like, you can basically trip them, right? Okay, so it also requires closing and tripping. So basically the closing and tripping occurs individually for each phase. It is very complex, yes, because single phase and single tripping and all those things are very complex, and it requires dedicated softwares to achieve that, and it can be very expensive, right? So that is why most utilities opt for this one, unless of course you have a particular customer that basically requires this for certain applications. Okay, so this is the working model of the auto reclosing, right? Okay, so this is the breaker, right? Okay, so this is the auto recloser, and this is the recloser, SEL651R, right? Okay, so this is basically the substation, right? And this is the source, right? Okay, so if you have a distribution substation, right? Okay, so let's say 13.8 kV or 12.47 kV, right? Okay, so the controller requires inputs from the CT and the PT, right? So definitely the PT comes from the bus, right? Okay, and the CTs are on the line, right? Okay, so the PTs are shunt connected and the CTs are basically series connected with the auto recloser, right? Okay, so these basically provide input to the controller, and also it requires the breaker status. Remember, the 52A contact, right, is the one that provides the status of the breaker, whether the breaker is closed or open. So the 52A is the one that tells the breaker that the breaker is closed, and the 52B is the one that provides indication that the breaker is open, right? Okay, so these are all the inputs that goes to the controller, and the controller is the one that is located, at the lower part of the pole, right? The auto recloser, it's located on top of the pole. So this is the auto recloser, and this is the automatic recloser, SEL651R. Okay, so now let's consider, normal condition, right? Okay, so basically, then all of a sudden the fault occurs, right? This is the permanent fault that occurs, right? Okay, so once the fault occurs, right, basically 50 element trips the circuit, right? Okay, so once it trips the circuit, right? Okay, so this is the breaker, right? That has the 50 element of the recloser, right? This recloser has 50 element and 51 elements, 50 and 51 n elements, right? Just like a substation feeder relay. Okay, so then it has a 79 element, right? That will reclose the circuit, right? Okay, so once it recloses the circuit, because the fault is a permanent fault, right? It's going to trip again. So the 50 element trips again. Then another attempt to reclose. Then it trips again because the fault is a permanent fault, right? So it tries all this sequence so that by the time, if it is a temporary fault, right, by the time that temporary fault would have basically be gone away or ionized, like a lightning strike, right? By that time, the ionization of the area would have basically been extinguished and the fault would have been cleared, right? So that is the reason why the auto reclosing action goes through that sequence, right? Unless, of course, you have a dedicated customer that is basically power quality is so important. The customer does not want any blips in their power quality, right? Because when the auto reclosing action takes place, open and close, it causes a temporary dip in the power. And sometimes, depending on the customer, if the customer has basically, let's say, if you have a foundry, right, or basically, a fabrication facility that basically deals with semiconductors, right? They basically do not like those temporary dips in power. So as such, they will rather allow the fuses that are downstream to take care of the fault instead of the auto reclosing, opening and closing, right? Okay, so and also they will like the auto recloser just to trip the feeder and basically open, not any reclosing action. So why? Because the fault basically it tries the third time, right, and it trips again, right? Then it tries the fourth time. Then, because the fault is the permanent fault, it locks out, which basically requires a manual intervention. The controller is basically what is located here, and it is located about halfway on the pole, right, within reach of operation personnel, right? Okay, so that the operator can go there and basically do all the settings and retrieval of relay settings, and also be able to program all the set points and alarm set points and coordination with the RTU and SCADA system. Right. Okay. So in front of the panel, this is what you see, right? And basically, it's able to provide you all the mid-range, reset targets, events, alarm test, and also settings, right? Okay. Provide you all the information that you need. Okay, so on top of the pole is the recloser. This is what you see. This is the recloser. Okay, so this is phase A, phase B, phase C, right? Okay, so this is the controller, right? Okay, so this is basically, a mimic of an operator, right? Operating, the recloser, right? Open and close. That is manual operation of the breaker, right? Under normal circumstances, if the operator is not there, right, then basically it's this controller that takes care of this recloser, right? Okay, so this is also another picture of a recloser, right? Okay, so as you can see, this is phase A, phase B, and phase C, right? Okay. Okay, so basically, these are vacuum breakers, right? Okay, so basically, within the contact, it has vacuum, right? Basically, to extinguish any arcing that occurs, right? Okay, so basically, operation of the recloser, right? You see the indication, just like a breaker, right? Open, right? For each phase, right? Okay, so if you're manually operating this, this is what you see: open, or close. If you choose to close it. Okay, so this is also another recloser, right, from a different manufacturer, and basically shows phase A, phase B, phase C. Okay, so now let's take a look at the timing sequence of auto reclosing, right? Okay, so basically you have a protection relay, right? Okay, so a protection relay basically is integrated to CTs and BTs, right? Current transformers and BTs that basically senses current and voltage, right? Okay. So then when there's a fault condition, right? Okay, so the relay has a algorithm, right? And basically has an operating time, right? Okay. So then it operates, right? And the algorithm processes the current transformer signals for signals, right? Then it issues an output to the trip call of the circuit breaker, right? Okay, so the trip call is going to get energized, right? Okay. So sometimes, some of these breakers are depending on, I think that most often they have only one trip call for medium voltage applications, but for high voltage applications, they have two trip calls and two closed calls. Okay, so the trip call gets energized, right? And once it gets energized, right, after a period of time, the contacts start to all separate, right? So the separation of the contacts, right, basically creates an arc which needs to be quenched. So that is when either the vacuum or SF6 comes into play, right? So there's a quenching medium, right, to basically mitigate any restrict action based on the voltage that is developed across the contacts, right? Okay. So then, whilst the contacts are trying to separate, like I said, the arc develops, and that arc needs to be extinguished, right? Until a time that the contacts fully open. At that time, the protector relay resets because it has basically completed its job and the breaker has fully opened. So that is the first reclosing action from the opening action from the breaker, right? Okay, so after that, then that's when the 79 element, the reclosing element, comes into play after the breaker has opened. Then the reclosing element, the 79 element, issues a command, right? After this period of time. So next is to close call energize, right? So it issues a command for a close call to get energized, to close back the contacts of the breaker, right? So after that, then the protector relay comes into play, okay? It needs to open up the breaker, right? After the close action of the 79 element. So the protector relay issues another trip command to the trip call, right? Where the contacts separate. Then during the process of the contact separating, an arc is developed, and that arc needs to be quenched either by vacuum or SF6 until the contacts are fully open. So this process basically continues until, based on the number of programmed opening and closing by the 79 elements, until the 79 element locks out and prevents operation of the breaker. Next, let's talk about the advantages of the auto reclosing process, right? So I have explained in detail the purpose and the meaning for auto reclosing. The 79 element, which is very important, which can either be part of the substation feeder breaker relay, and especially the SCL 451 relay has that reclosing element, 79 element, as part of the relay, right? Or it can be a dedicated recloser that is midway on the radio feeder, right? So these are the advantages. It increases the stability of the power system distribution system. Because under normal circumstances, without an auto reclosing function, right, the circuit breaker is going to trip for temporary fault, for transient faults that do not require tripping and making power unavailable to many customers, right? But an auto reclosing function and equipment allows a temporary dip and reclosing action to restore power to many customers, right, to prevent outage to as many customers as it would have been also eliminates the need for operators to go all the way to the remote location. And some of these distribution feeders can be very very remote. And sometimes even identifying where the fault is can be very challenging, especially if you don't have a fault identification system on the distribution system, right? So it eliminates that need. And what does it translate? It eliminates the cost, labor cost, maintenance cost, travel time to these remote areas. It eliminates unnecessary outages. Yes, because if the feeder breaker from a substation had tripped based on transient fault, temporary faults due to lightning, then it would have created unnecessary outage that is not needed, right? But the reclosing action basically eliminates, mitigates that. It improves systems reliability. Yes, of course, because of reduction in side fee, side E, and my fee indexes. And basically, auto reclosing, basically, it's an automation scheme that allows a smart grid to be achieved, right? That is automation of the distribution network. And that is part of a digitalization of the transmission and distribution effort that every company, every utility is trying to achieve. With that comes to the end of my presentation, and thank you so much for your listening ears. And then again, my good name is John Kweko Amoto. I've been a professional electrical engineer for the past 31 years. I'm based in the United States of America. And thank you so much for all the time, all the effort to listen to this video. If you like this presentation, don't forget to select the like button and share these materials to all your friends, right? And you can go to my YouTube channel, What Can Happen is Talking to the Engineer, and there are tons of presentation materials that is will help you as a power systems engineer. And for you to be able to access and subscribe to this channel, you need a Google account and Gmail. Okay, and this is the subscribe button. Okay. With that said, thank you so much, and look forward to more videos, presentation on technical materials, technical information, and basically sharing that knowledge across the globe.